Good morning, friends. Today we are going to start our discussion about new chapter, thermodynamics. Right? The name is thermodynamics. That means the dynamic due to the exchange of the heat. Right? As the exchange of the heat take place, or the heat of the or the temperature of the system change. So which type of the changes occurs in the system we are going to discuss in this chapter. Right? Now, before starting our discussion about the thermodynamics, first what is to explain the difference between the mechanics and thermodynamics. What is the difference between the mechanics and thermodynamics? Already we discussed about the mechanics. Mechanics, that means the branch of the physics deal with the motion of a body due to the force acting on it or the torque acting on it. That is known as the mechanics. While in thermodynamics, there is no externally force or the torque is applied on a system. But due to the exchange of the heat or due to the change in temperature, the particles of the system perform the motion. As a result, the pressure, volume, temperature, internal energy of a system is going to change, and this type of the study is known as the thermodynamics. Clear this? Again, what is the mechanics? In mechanics, the motion of particle under the action of the forces and torque also can be described. We can describe the motion of a body or its particle under the influence of the force or the torque acting on it. Already we discussed about the mechanics in chapter 3 and 4. Motion of a particle in one line or in one dimension and also in 3 dimensions or in a plane. Okay. Again, what is the mechanics? In mechanics, motion of the particle under the action of the forces and torques. That also can be described. While before starting our discussion about the thermodynamics, what is the system and what is the environment or the surrounding? A part that can be described by the thermodynamics state variable is known as the thermodynamic system. In short, the part of the universe which consider under the thermodynamic study. Suppose that is the room. We are interested to learn about what is the pressure, volume and temperature of this room. So this room is our thermodynamic system for this type of the study. That means the part of the universe considered under the thermodynamic study is known as the thermodynamic system. Therefore, a part that can be described by the thermodynamic variable. Which are the thermodynamic variable? Pressure, volume, temperature, internal energy, and also the amount of the heat are known as the thermodynamic variable. Right? Again, the thermodynamic state variable are pressure, volume, temperature, heat energy, and also the internal energy. Are the constant or the variables which describe the thermodynamic state of the body. Therefore, a part that can be described by thermodynamic state variable is known as thermodynamic system. Clear this? Again, the thermodynamic state variables are pressure, volume, temperature, internal energy and heat energy are the thermodynamic variable. Thermodynamic state variable. By knowing the value of this physical quantity, pressure, volume, temperature, internal energy and also the amount of the heat, we can describe the state of the given system. What are the pressure, what is the volume, what is the temperature, internal energy and amount of the heat produced by the system. These are known as the thermodynamic state variable. Right? The part that can be described by the thermodynamic state variable is known as thermodynamic system. And what are the parts surrounding the thermodynamic system are known as the environment or the surrounding. Again, if the direct effect on a part around the system is known as surrounding or the environment, or everything external to the system is the surrounding. What are the surrounding of this room? Which direct effect take place on the system is known as the environment or the surrounding of the thermodynamic system. Initially, we consider this room as a thermodynamic system whose thermodynamic study, that means we are interested to find out what are the change in pressure, volume, temperature, internal energy and exchange of the heat. So this room is known as the thermodynamic system. The direct effect of the surrounding of this room take place on this room. Right? So what are the surrounding of this room? That is known as the environment or the surrounding of the thermodynamic system. Or in other words, if the direct effect on a part around the system is known as the surrounding or the environment. Or in other words, everything external to the system is known as surrounding or environment of the system. Clear this? So there is the definition of the thermodynamic system and surrounding or the environment. Right? In thermodynamic, there is the no external force or the no external torque is required for the motion of the parts, different parts of the system. Here, due to the exchange of the heat or the change in temperature, the particles of the system comes under the motion. So as a result, the pressure, volume and temperature are also going to change. Clear this? So there is the main difference between the dynamics and thermodynamics. In dynamics, the external force or the external torque is required for the motion. While for thermodynamics, there is no need of the external force or the external torque for the motion of the particles of the system. Clear? So that is the main difference between the dynamics and thermodynamics. Now after that, what is the meaning of equilibrium in mechanics and equilibrium in thermodynamics? So meaning of equilibrium in mechanics is that the net external force and net external torque acting on a system is zero. Already we discussed in equilibrium of a system, mechanical equilibrium. If the no any force is act on a body, so body maintain its state if there is the no external force act on it, according to the first law, Newton's first law of motion. When we apply the external force, the state of a body is changed. The same way, if there is the no external torque acting on a body, so we can say that the body is in rotational equilibrium. And if there is the no external force acting in it, so body is in translational equilibrium. So that is represented by Newton's first law of motion. If there is the no external force acting on a body, so the state of the body is remain constant. If the body is stationary, so it remains stationary, and if the body is moving with the constant speed, so its speed is also remain constant. Clear this? So in this situation, we can say that the body is in mechanical equilibrium. Again, the meaning of equilibrium in mechanics is that the external force or external torque on a system is zero. Now, what is the thermodynamic equilibrium? So, equilibrium in thermodynamics means that if the macroscopic variable, which are pressure, volume, temperature, internal energy, and amount of the heat, that characterize the system do not change in time. That means if this state variable does not change with time, so we can say that the system is in thermodynamic equilibrium. Again, the equilibrium in thermodynamics means If the macroscopic variable, like is the pressure, volume, temperature, amount of the heat, internal energy, do not change in time, then the thermodynamic system is in equilibrium. Clear this? Okay. Equilibrium state of a system depends on the surrounding and the nature of the wall that separates the system from its surrounding. Again, the equilibrium state of system depends on the surrounding and the nature of the wall. Nature of the wall that separates the system from the surrounding. Here initially we consider that our room is the system and outside of the room is the surrounding. Which direct effect takes place on the room? Now, the wall separating the system from its surrounding, that is known as the separation of the wall. What are the wall of this room? Are the wall of separation. Now, what are the pressure, volume, temperature, internal energy of a molecule inside the room? Suppose that does not change. That means, why that does not change with the remain constant? If the direct effect of the surrounding does not take place on the room. If the direct effect of the surrounding take place on the room, at that time the pressure, volume, temperature, internal energy of a molecule also changes. Right? So, the system is in equilibrium or not, that is depends on the effect of the surrounding on a system, and second, the wall separating the system from its surrounding. If the wall is conducting wall, so direct effect of the surrounding take place on the system. If wall are non-conducting, at that time the direct effect of the surrounding does not take place. Does not take place. When we go to see the cinema, the effect of the outside does not take place on inside the cinema hall. So as a result, we feel that the reality of the picture. But when we are observing the same picture in open, no wall, at that time our mind is not concentrated about the picture. In cinema hall, what are the wall of a hall are non-conducting. Therefore, the effect of the sound, effect of the temperature does not take place inside the hall. Right? So, in short, we are in thermal equilibrium inside the cinema hall. Clear it? Okay. Now listen. The equilibrium state of the system depends on the surrounding and also the nature of the wall that separate the system from the surrounding. Clear is? Again, first, what is the difference between the dynamics and thermodynamics? In mechanics, the motion of the particles under the action of forces in the toy that can be described. Again, in mechanics, the motion of the particles under the action of the external force and external toil, and this motion is also described, that is known as the mechanics. While in thermodynamics, first we define what is the thermodynamic system and surrounding. A part that can be described by thermodynamic state variable. Thermodynamic state variable are pressure, volume, temperature, internal energy, and heat energy. The part that can be described by the thermodynamic state variable is known as thermodynamic system. And also, what is the surrounding? If the direct effect on a part, this part, around a system is known as the surrounding or the environment, or the everything external to the system is known as the surrounding of the system. The thermodynamic is not concerned with the motion of system as a whole. thermodynamic is not related with the entire system is in motion. Right? It is concerned with the internal macroscopic state of the system. So in thermodynamics, not the entire system is in motion, but here it is concerned with the internal macroscopic state of the system. So here we are considering the room as a thermodynamic system. Here the thermodynamic system or the thermodynamic is not related with the entire motion of the whole. But here the motion or the thermodynamic state of the air particle filled in the room we are concerned, or the thermodynamic is concerned. So it is concerned with the internal macroscopic state of the system, and macroscopic states are also this: the thermodynamic state variable, pressure, volume, temperature, internal energy, and also the amount of the heat Q. So as a result, the air particle comes into the motion. So its kinetic energy, its potential energy, and also it suffers the collision during its motion. Again, the thermodynamic is not concerned with the motion of a system as a whole, and it is concerned with the internal macroscopic state of the system. Now, what is the meaning of equilibrium in mechanics and equilibrium in thermodynamics? In mechanics, equilibrium, or the meaning of equilibrium in mechanics is that the net external force and net external torque are zero. If there is no force act or the torque act on a system, the system comes into or attain its state for the long time. That means the state of the system does not change if there is no force or no torque acting on it, according to the first law, Newton's first law of motion. So the meaning of equilibrium in mechanics is that the net external force and the torque are zero. Now, equilibrium in thermodynamics means that if the macroscopic variable that characterizes the system does not change with time. What is the meaning of thermodynamic equilibrium? The meaning of the thermodynamic equilibrium that the macroscopic variable like as the pressure, volume, temperature, internal energy and amount of the heat does not change with time. That is the main constant. So we can say that the system is in thermodynamic equilibrium. Now, the equilibrium state of a system depends on the surrounding and the nature of the wall separate the system from the surrounding. So thermodynamic equilibrium depends on the nature of the surrounding and also what is the wall separate the system from the surrounding. After that, now we are going to discuss about the thermodynamic equilibrium. Explain the thermal equilibrium in the system. How we can say that this body or this system is in thermal equilibrium? We have the experience in the body as we fill the hot tea in a cup. So what's happened? The heat is exchanged from the tea to the environment or the atmosphere. After some time, what's happened? The temperature of the environment and also the tea becomes the equal. So what's happened here? The heat from the hot tea is exchanged or transferred to the atmosphere. That means the flow of the heat energy takes place from tea to the environment or the atmosphere. So as a result, the temperature of the tea decreases while the temperature of the atmosphere is going to increase. After some time, the temperature of the atmosphere and also the tea becomes the equal. When the both temperature becomes the equal, at that time, the exchange of the heat between the tea and atmosphere does not take place. So this situation is known as the thermal equilibrium of tea. That is known as thermal equilibrium of tea. So here we explain this thing by considering the example of two gases A and B separated or the filled in two separate containers. As shown in figure, consider two gases A and B. Suppose the pressure and volume of the gases A and B are PA, VA. That is the pressure of gas A, volume of gas A is VA. And pressure of gas B is PB and volume of gas B is VB respectively. So in figure A, both containers are separated by the adiabatic wall. Adiabatic wall, that means there is the non-conducting wall. Non-conducting wall. Suppose the temperature of A is more than the temperature of the B. Now both are connected with each other by the non-conducting wall, that means the adiabatic wall. So what's happened? There is the no flow of the heat from hot to the cold part or the from A to B, because the A is supposed to hot and B is cold. That means the temperature of the A is more than the temperature of B. But both are separated by the non-conducting or the adiabatic wall. Therefore, the exchange of the heat does not take place. Exchange of the heat does not take place. Suppose this adiabatic wall is replaced by diathermic wall. Diathermic wall, that means the conducting wall. At that time, what's happened? The heat is always flowing from higher temperature to the low temperature. Again, the heat is always flowing from higher temperature to the low temperature. As a result, the temperature of the gas A decreases while the temperature of the gas B increases. After some time, when the temperature of the both gases becomes equal, there is no exchange of the heat take place. Because the temperature of the gas A and B are same. So in this situation, the pressure, volume, temperature and internal energy of a system becomes the same. So we can say that there is no exchange of heat. It means the both gases are in thermal equilibrium. Both gases are in thermal equilibrium. Again, as shown in figure, consider two gases A and B. Suppose the pressure and volume of gas A and B are PA, VA and PB, VB respectively. In figure A, both gases A and B are separated by adiabatic wall. Adiabatic, that means the non-conducting wall, so that the flow of energy, that means the heat, does not take place from one to the other gases. From one to the other gases. Now, suppose the adiabatic wall is replaced by the diathermic wall, that means the conducting wall as shown in figure B, which allow the heat energy to flow from one to the another gas. So due to the conducting wall, now the exchange of the heat take place between these two gases. The macroscopic variable of the system A and B changes spontaneously. Now, the macroscopic variable of the system A and B changes spontaneously until the both systems attain the equilibrium. So, due to the replacing of the adiabatic wall by the diathermic wall, so what's happened? The macroscopic variable of the both system changes spontaneously till both the system attain the equilibrium. After that, there is no exchange in their state. When the equilibrium, that means the value of the state variable becomes the same, at that time there is no change in their state. The pressure and the volume of the two gases becomes PA dash, VA dash and PB dash, VB dash, such that the new state of A and B are in equilibrium with each other. That means when the adiabatic wall is replaced by the diathermic wall, so exchange of or the exchange of the heat, or other words, the changes take place in the macroscopic variable spontaneously. When it attains the equilibrium, after that there is no change in their state. So we can say that the new volume and pressure of both gases are PA dash, VA dash and PB dash, VB dash. such that the new state of A and B are in equilibrium. So it is called A is in thermal equilibrium with B. Clear? Where is he? Only we have to describe the figure. Initially the two gases are filled, A and B. Right? Consider the two gases. The pressure and volume of A and B are PA, VA and PB, VB respectively. In figure A, both gases are separated by the adiabatic wall, that means the non-conducting wall. So that the flow of energy or the heat do not take place from one to another. Now in figure B, suppose adiabatic wall separating the gas A and B is replaced by the diathermic wall, conducting wall, as shown in figure B, which allow to flow of heat or the energy from one to another gases. So due to the conducting wall, what's happened? The macroscopic variable of the system A and B change continuously or spontaneously until both the system attain the equilibrium. After that, there is no change in their state. The pressure and volume of the two gases PA', VA' and PB', VB' such that the new state of A and B are in equilibrium. And there is no exchange of the heat. Right? And that is known as the A is in thermal equilibrium with B. So after the discussion of the thermal equilibrium, that means if the two systems we have both have the same value of its thermodynamic state variable. So we can say that the both systems are in thermodynamic equilibrium. After the discussion of the equilibrium of thermodynamics, we are going to start our discussion about the zeroth law of thermodynamics. Clear? Okay.